sinusoidal function is a periodic function whose rule can be written as a sine or cosine function. In this video, we are looking for the rule of a sine function. Before we start, let's look at some of the properties that will help us determine its rule. The axis of oscillation, or midline, is the horizontal line that passes through the middle of the function. All the points that cross the axis of oscillation are called inflection points. In a sine function, these points help define the values of h and k. The amplitude, denoted by capital A, is the distance from the axis of oscillation to the minimum point, or from the axis of oscillation to the maximum point. To calculate it, subtract the value of the minimum point from the value of the maximum point, then divide by 2. The amplitude is used to find parameter A. To find the period, we must locate a cycle, which is the portion of a wave that repeats itself. The period, denoted by capital P, is the range between the two values of x at the end points of one cycle. The period allows you to find parameter B. Let's look at the first example. Consider the following sinusoidal function. To find its rule, the values of parameters a, b, h, and k must be determined. Let's start by determining h and k by sketching the axis of oscillation, or midline. Since the maximum is 3 and the minimum is -5, the horizontal line through the middle is y is equal to -1. Its equation can be obtained by adding the maximum value 3 to the minimum value of -5, then dividing by 2. We're essentially calculating the mean between the two. The inflection points are now much easier to locate. As you can see, there are several possible answers, including the points -π/3 -1, π/3 -1, π-1, and many more. All these answers are correct. Let's choose the point π/3 -1, so h equals π/3 and k is -1. Now, to find the amplitude and the period, we draw a rectangle, framing a cycle, and starting at the chosen point of hk. From the point π/3 -1, the function rises slightly, drops all the way down, then rises back up again until it reaches the axis of oscillation. This is where we stop, as it marks the end of a cycle. Draw the rectangle. Now we are ready to calculate the amplitude using the following equation. Maximum minus minimum divided by 2. In other words, 3 minus -5 divided by 2, which gives 4. At this step, the answer is always positive, which is why it is the absolute value of A. Its sign will be determined a little later on. To find the value of B, we use the following equation. P equals 2π divided by the absolute value of B. The period is the horizontal interval between the beginning and the end of the cycle. That is, the length of the base of the rectangle. In this case, the period corresponds to the distance between π/3 and 5π/3. Here's a trick. When subtracting fractions with pi values, subtract the fractions in the usual way. In other words, 5/3 minus 1/3. The answer is 4/3. Must include pi. This gives 4π/3. Now replace p with 4π/3 and cross-multiply to find the absolute value of b. This gives 2π times 3 divided by 4π, which equals 6π/4π. We can simplify this fraction by dividing by 2 and canceling out the pi, resulting in 3/2, or 1.5. So the absolute value of b is 1.5. Now we need to determine the signs of a and b. Look at the curve of the function starting from hk. If the function is increasing, a and b have the same sign. If the function is decreasing, a and b have opposite signs. In this example, the function is increasing, therefore a and b have the same sign. Both can be positive or negative. You choose. Note that if the hk values chosen at the beginning had been different, other answers would also have been possible. We have now found the rule of this sinusoidal function. Let's do a second example with the following function. The first step is to find parameters h and k. To do so, we trace the axis of oscillation, or midline, which passes through the middle of the function. Since the highest point has a y-coordinate of -0.5 and the lowest point has a y-coordinate of -3.5, the equation of the axis is y is equal to -2. Next, we need to locate the inflection points. Once again, several choices are possible. Let's take the point -3, -2. This means that h is -3 and k is -2. From this point, we draw a rectangle encompassing a full cycle of the function whose base length corresponds to the period. We are now ready to calculate the absolute value of a. To find a, we must subtract the minimum from the maximum and divide the result by 2. In this case, that translates to -0.5 minus -3.5 divided by 2, which results in 3/2, or 1.5. Now only parameter b is left to be calculated. To do so, we use the equation p equals 2 pi over the absolute value of b. The cycle starts at x equals -3 and ends at x equals 4. Therefore, the period is 7 units. Replace p with 7 and isolate the absolute value of b. This equals 2 pi over 7. The last step is to determine the signs of a and b by analyzing the function, starting from point -3, -2, which is our hk. Since the function decreases, from this point, a and b have opposite signs. You could make a negative and b positive, or a positive and b negative. You decide. That's it. We have the rule for the sinusoidal function. Hopefully, this video helped you understand how to find the rule of a sinusoidal function using the sine function. If you want to learn how to graph these functions, we have a video for that too. Check it out.